Hey class, Miss Tessler here for another lesson. Think for a moment, then tell me, when have you used tape diagrams and number bonds with whole numbers? Maybe you remember using these models to add and subtract. These models help us to see parts and totals. Today, we'll use them to add and subtract fractions and whole numbers. Think about how this might be similar to what you've done before. All you need today is paper and pencil or your personal whiteboard. So let's dive right in. Answer in mixed units. 2 meters plus 5 centimeters is 2 meters, 5 centimeters. 2 hours plus 5 minutes is 2 hours, 5 minutes. 2 ones plus 5 eighths is 2 ones and 5 eighths. Let's use a tape diagram to model adding a fraction to a whole number. Here's the problem. 2 plus 1/2. What should we model first? We can model the whole number 2 first. Pause here and draw a tape diagram to represent 2. Ready? Here is 2. The solid lines show where each one is. We need to add 1/2. Pause and use dotted lines to decompose 2 into halves. Ready? Now that we can see the size of each half, we can add on 1/2. Pause to add 1/2 to the end of your tape diagram. Ready? There it is. Now, how much do we have in all? What is the sum of 2 plus 1/2? Write it as a mixed number. It's 2 and 1/2. Let's use a number bond to represent this sum. What would that look like? Draw a number bond like this. What is the whole or total, and what are the parts we combined? The parts we added together are 2 and 1/2. The word whole is interesting. We can use it to describe a whole number, like 2, and we can also use it to describe a total amount, like the sum in this problem. I love how fractions get us thinking about parts and wholes in so many different ways. Anyway, what's our whole here? What is the sum of 2 and 1/2? That's right, it's 2 and 1/2. Fantastic. Shall we try another? In the last problem, we added a fraction to a whole number. This time, we will subtract a fraction from a whole number. How can a tape diagram help us model taking a fraction from a whole number? Here's our next problem to solve. Write it and read it out loud. This time, let's draw it as a number bond first. We can fill in what we know and use the letter X for the part we haven't figured out yet. What will that look like? Pause here to draw your number bond. Ready? Here's mine. We're taking away 1/4 from the total 3. Does it matter which of these two circles you put 1/4 in and which you left a mystery? Nope. Both show the relationship between the part we're taking away and the whole we're taking from. Now, model with a tape diagram. What part will you model first? Pause to draw. Ready? Here's mine. Did you also model 3 first? Now, let's subtract 1/4. Where is 1/4? I don't see any fourths, just 3 ones. How can we create fourths in this model? We can decompose the last 1 into 4 parts. Follow along with me. There. Now I see 2 ones and 4 fourths. Is that enough to take away 1/4? Yes, let's cross it out. How many fourths are left? 3/4. Is that the answer? Oh, right. There's the rest of the tape diagram too. We didn't take anything from either of these ones, so we also have 2 ones left. How much do we have left in all? 2 3/4. Can you add that to the number bond? Interesting. In the addition problem we just did, our answer was the total here. And in the subtraction problem, our answer is a part here. Way to use your strong, flexible mind. I'm curious now, what would this problem look like modeled on a number line instead? Here's a number line showing 0 to 3, just like the tape diagram. And we can partition this one into fourths, then show counting back by 1/4. Where do we land? When I read a number line, I like to imagine running in a race. Pass 1, pass 2, stop at 2 3/4. Great work. Let's go on. Write this expression and read it out loud. 5 minus 1/4. We'll model this one together with a number line, but first, draw a number bond to match the problem. Use a letter to represent the missing part and think about your strategy for solving. Hit play when you're ready. Ready? Here's my number bond. How are you thinking of solving this one? You got this. Time to model with a number line. Here, I drew one that goes up to 5. Whew, oh boy, this number line takes up my whole page. Do we really need to show this whole thing? We're only taking away a little bit. What else could we do? I think we can zoom in on just the part we need to solve the problem. Am I correct in thinking that what we're subtracting is less than 1? Yes, it's just 1/4. And I'm thinking of 5 as 4 4/4. So I think we'll be good to go if we only show between 4 and 5. Number lines are flexible like that. Pause here to draw a number line with 4 and 5 as the endpoints. Ready? Here's mine. Now what? Decompose the number line into fourths, then show a hop to subtract 1/4. Where do you land? Complete the number sentence you wrote with your answer. Pause and hit play when you're done. Ready? Here's my number line decomposed into fourths. And here's my number line showing 1/4 subtracted. So we found that 5 minus 1/4 is 4 3/4. Great job. Find space for another. Now try this one on your own. Write the expression and read it out loud. 7 minus 3/5. Draw a number bond to match. Think about your strategy, then model with a number line. Pause here and hit play when you're done. I can't wait to see your work. Ready to check? Take a moment to compare your work with mine. Does your number bond have this total and these parts? Did you decompose 7 into 6 and 5/5? Were you left with 6 2/5 after subtracting 3/5? You are doing amazing. Now let's focus in on the number bond. Take a moment to think and then tell me, how are these numbers related? One of them represents the whole or total, and the others represent the parts. Here is the equation you just solved. Hit pause, write one more subtraction equation and 2 addition equations that use these numbers to show how they're related. Ready? Take a moment to compare your work with mine. Notice how each equation is a different way to represent this part-whole relationship. You might even visualize a tape diagram or a number line in your mind for each equation. Hit pause and try on your own with these numbers. And the equations are, did you get them? I am so proud of you for working these out with me today. Give me a high 4 1/3. Now you're ready for the problem set. The must-do problems are on the screen. Set a timer or watch the clock for 10 minutes to work on these problems. If you finish